My name is Mark Bolinsky. I'm the Senior Technology Architect here at InterSystems. We're a small group of 5 of us worldwide, and we take care of system sizing and planning for all of our products. HealthShare, TrackCare, Iris, Cache, Ensemble, all of those things. So we dabble a lot within, or actually more than dabble, within cloud, hardware, on-prem. But today we're going to talk about how to make your cloud deployment cost-effective and cheap. Cloud means a lot of things to a lot of different people. When I think of cloud, I think of 3 main things. Cloud can be convenient, and it certainly is. Cloud can be expensive. It doesn't have to be. And it can also be difficult to deploy. Again, it doesn't have to be. There's some areas where networking, I'm not going to be touching on that today because networking in itself can be quite complex, because you just think about what a cloud is. You're standing up an entire data center within the cloud. So from that aspect, I'm not going to touch on it because there's a lot of security implications and operations just on the network side that comes into play. But strictly speaking of InterSystems products, we'll focus on Iris today, on what it means to make an InterSystems Iris deployment cost effective. So we think about those 3 areas. So where does the cost live? Compute, storage, networking. Storage is especially the most costly because that's the only resource that can't be oversubscribed. You figure you can only occupy that sector of disk or that cell on an SSD, so you're going to pay a premium for it. Now, the nice thing about that is year on year, the cost per gigabyte within cloud is coming down significantly, and even for going for the SSD storage, which I'll be the first to advocate, or I'll only ever advocate, is going to SSD storage. Using spinning rust, disk, is never an option, in my opinion. So if we look at the compute resources a little bit, so there's many choices around different options. There's general purpose, compute optimized, memory optimized, storage optimized, and then there's other specialized options as well in different instances based on the cloud provider. There are various combinations of CPU, memory, and it really depends on what your application requirements are and what the specific roles are. So if you're talking a database server versus an app server versus a web server, your resource requirements are going to vary significantly. But the really cool thing about it, going back to that convenience, it really is just a click away to change from one instance type to another, so on and so forth. Thinking a bit about storage resources. Now, this is where there's a lot of different options. So there's your persistent disk or block storage, which is most commonly used. There's your object storage, which is your S3 buckets or your objects or blob storage. There's also file storage, where you can mount up NFS or CIFS. And each one of these have their own niche or perfect use case for them. And then I also forgot to mention there's local storage as well. And I'll come back to local storage in a bit. Being ephemeral, and what I mean by ephemeral storage is that it's persistent until you stop and start the instance itself, and because there's never a guarantee you're going to restart on that same physical host again, there's no guarantee that your data can be used there. But I'll explain how in this session and in my next one, so a commercial for my next session, on how you can actually leverage this. And then talking about network resources. So again, there's countless options. You have your internet, your VPN gateways. You can do direct MPLS, dedicated bandwidth. Each one of these comes with a cost, especially when you get into the direct connect ones with your MPLS. Like, not only do you have to pay for your telecom bandwidth itself, but the cloud provider also charges you money to have that port on their switch access. So you want to be mindful. Your SLAs and your business SLAs to your customers will dictate a lot of that, of what the requirement is. In most cases, a VPN gateway between your data center or a customer and to your cloud deployment is probably enough. But sometimes, depending on internet bandwidth fluctuations and latency fluctuations, routing, that might not be good enough. So you might have to get into using a direct connect. And all the cloud providers provide that capability. Azure Direct, Express Route, blah, blah, blah. So there's a lot of different options from the cloud providers. So if we dig a little deeper into the compute resources, and specifically looking at it from making it cost effective, how you used to allocate resources, I'll say traditionally, or before the cloud era, you'd plan well in advance, a year, multiple years in advance. With cloud technology now, because everything is so convenient, you want to size for just enough for now. And when you think about cloud, you only want to pay for what you need, and you don't want to be over provisioning. So you'll hear me say throughout, you really want, just enough for now is really what you want to be focusing on for a cloud deployment. When getting into the just enough for now, so traditionally, again, I talked about you have your CapEx model, you have to go through budgeting, pre-buy, maybe a couple $100,000, millions of dollars of hardware, it's a big chunk of money, and then you amortize that or whatever, or depreciate it over 3 years, 5 years, whatever it may be. Big money out of pocket, and who knows what's going to happen. Projects may change within 2-3 years. Resource requirements may change within 2-3 years. So now you have this resource and huge amount of money invested in infrastructure that could become obsolete in 2-3 years, especially with the way how technology is changing so rapidly. I mean, even within SSD storage space, I mean, traditionally you went from spinning disk with the big controllers and all that, and you had to spend millions of dollars just to get, maybe 100,000 IOPS. Now you can go out and get an NVMe SSD that can do 400,000 IOPS on one single disk. So going to cloud removes you from that CapEx, and you can purely go to an OpEx model where you're only paying for what you're using right now. There's no benefit to over-provisioning for growth because it's just wasted money, wasted resources that could be spent better somewhere else. You'll also hear me throughout is monitoring and knowing your workload becomes very important, especially in cloud. You want to be knowing what your utilization is at all times and monitoring proactively and also from a historical trending to allow you to go into future forecast capacity trends. By the way, if there's any questions, please feel free to blast them out to me as we're going. I certainly welcome that throughout. So if you have a question, please just shout it out. Either come up to the microphone, yell it, and I'll repeat it, and we'll go on. So just focusing in more on the just enough for now. Mentioned earlier, cloud is convenient. It's readily available resources, and gone are the days of pre-allocating resources. So if we start digging in a little bit into different scenarios and how you can do it. So we look at load balancing in the past, or I'll call it legacy. In the past, you would say, okay, well, I need to size for my peak workloads of what business or what my workload will be during maybe I have a normal, between 8 a.m. and 11 a.m. and then again from 1 p.m. to 3 p.m. utilization is really high. So you have to size for that. So you have to provision your resources, whether it's virtual machines or bare metal servers, AIXL PARs, whatever it may be. You have to provision it and sit it and put it out there, and it runs all day, every day, whether it's being utilized or not. So just using simple load balancing rules, you can say, well, okay, I know what my workload is going to be between these hours. You can programmatically or even manually saying, well, okay, I'm going to add another application server to this load balance pool. And it's a manual process. I'll get into some more advanced features of doing that dynamically in a bit. So here, same situation. If we say, well, if we take a normal 12-hour, if we assume a 12-hour time slice throughout the day, you control or know what that utilization is going to be, or at least at a peak. So that way you can make a resource change maybe once or twice a day. You're saying, okay, I need 4 application servers during my peak, but maybe at night you only need 1 or 2, maybe 2 for resiliency and continuing HA. So that in itself is going to save you a significant amount of money. Then you can get into using scalability groups or scale sets, depending on the cloud, all the different cloud providers. So you'll see my diagrams up here. They're AWS focused, but all these concepts apply to GCP or Google Compute Cloud or Cloud Platform, Azure, AWS. All the concepts are the same. It's all a matter of semantics and what they call it. But basically the concepts and the fundamentals are all the same. So you can do the same thing, but in a more dynamic way and even on a regular interval. You put your application servers or web servers, whatever it may be, into a scalability set. And so that way, through monitoring using the cloud services, it can dictate and know when you need to add resources when certain thresholds are being set. So it can be done on a regular period, how often you want, based off thresholds. So you can have, throughout the day, your utilization could change significantly and the allocation of application servers. So users can get drained off from one to another, so you can grow and shrink dynamically, and that's going to save you a significant amount of money, especially if you think about application servers where that's where all your compute resources are usually going to be. If you're in a true 3-tier model where you have web, app, DB tier, your app tier is where all your compute resources are typically going to be. Using this model, the cloud itself will provision it. So you'll create what's called an AMI, where it's a pre-built image, which has Iris already installed on it, or even cache pre-installed on it. It might have some of your software already pre-built into it. When this scalability set identifies it needs more resources, it will go out and grab that AMI, pre-build it, add it to the load balancer pool, and it's all done dynamically. You don't have to touch a thing. And same thing with taking away resources, so it'll start scaling back at night. So I talked about application servers where you can get into scaling it, either a manual process where you add them right before your morning hours and take them off in the evening, so at night you have not over allocated resources. But then there's also, if we talk about the database tier, where it's more of a known capacity based. If you have either maybe just a 2-tier model or a single-tier model where you don't have application servers, so your users or interfaces or whatever it may be running directly on the database server tier itself, this is where you can start leveraging other options, such as our failover mirroring, changing an instance type under the covers, and I'll show you how the different cost models will pair out and the savings that you can realize throughout a year. So we have two based options here, and we'll focus on the database tier. The one on the left here shows no application servers. So you could have at night, or even if you want to take the day as a risk during the day, you allocate your full resources. Here I'm showing, I think it's an R4, 4 extra large instance. And if you want to run the risk saying, well, just in case a failover happens, it may be rare, maybe common, it's up to you to decide. But maybe you only want to run your mirror member as a smaller instance type. You can always change it later, or if you want to do it, this model, during the day, both mirror members are running at the large size, so that way if failover occurs, you have the same capacity. Or in the evening, when you say, well, I know utilization is going to be lower, you can shut down the backup mirror member, and this is a manual process. You can automate it through PowerShell or AWS CLI commands, so there's a lot of options you can do to automate this for you. But at night, shut down your backup mirror member, change the instance type, bring it back up, and then fail over to it, and then do the same on the other side. So then during the night, you're running just on a single tier, you're running at less resources at night. And then during the day, you preemptively do the same failover. So there'll be a small blip to do a planned failover. It's usually a few seconds, and mirroring allows you to do this kind of manipulation, but there is that short, brief interruption of utilization. So just to show you some example of the cost savings that can be realized. So in this example here, if you run this is the single tier, no app servers, 100% utilization, so we have two, R3 or R4, 4 extra large, it'll cost you a little over $2,100 a month. And so you have your full failover capability, 24/7, full resources. Now, if we go to 50/50 at that planned capacity where we're saying, okay, I want more resources during the day for a 12-hour period and less resources at night, it's going to save you about $1,000 a month just by doing that. And then you multiply that out over a year, so now you're talking $12,000 in savings just by running reduced capacity at night. Using that same example with application servers, it's roughly about a 50% savings. So here in this example, we're going to run 2 database servers. The 2 extra large, we can run a smaller database server instance type because all your compute's up on the app tier. and then run 4 application servers at 100% utilization all day, and it comes out again, around $2,100 and change. But then if we take the same approach that we did before of combining both planned capacity, failover your database servers to something smaller, but then also using either scale sets or planned adding and removing application servers on your own, that's going to save you even more money per month. And it can be done dynamically. Any questions?
Yeah, hey Mark. So in your top example, the second one, 50%, 50%?
Yep.
You're going to take down the primary and make it a backup? Is that fill the backup?
Yeah, so the question is are we going to take down the primary and fail over to the backup? What you would do first is shut down the backup, change its instance type, and this is in a scenario if you had both running at the same instance type for the same resources, not one running at a reduced. Shut down the backup first, change its instance type to have maybe half the resources, then do the failover once you bring it back up, and then you can change the other one.
I guess I'm worried about, like, when I go to bring up the larger one later on, is there going to be lag time because it has to catch up all the updates?
No, so what you'll do is once you fail over, you then shut down what was the primary, change its instance type, bring it back up, so that way it'll catch back up. And so that will be running both mirror members at the lower capacity. Any other questions? So this second example is also, it's leveraging the scale sets. One added benefit I want to add to this second option here is because you're using ECP, ECP will preserve your ECP session in the user's context. So that way when the failover happens, there will be no disconnection. So when the failover will happen, it will be completely transparent from the user. They may see a slight pause, if they happen to be doing an ECP reference that required an actual communication across to the database tier. But other than that, worst case, they see a pause. Best case, they don't see anything. Any questions? Cool, okay. Now this is the really fun one. So now we're going to talk about storage resources. Compute, no other questions on compute? Storage is where you're going to have a big savings on in a cloud, and by being smart and proactive about it. So again, it's going back to right sizing and planning for now. No longer saying I'm going to allocate storage for N number of months, N number of years, blah blah blah. It's just maybe for a few days or a few weeks out. And this is where the monitoring comes back in place. So you need to know your historical trending, and so you can forecast out, saying, well, okay, I'm going to grow 10, 12% a month or 10, 12% a day. It's knowing and having that monitored data to understand to run it close to this edge. Tons of different storage options. There's different tiers within the different storage options as well. You can even use, like I said earlier, you can use the local storage if you're smart about it. I know it sounds scary, but these local SSDs, and I'll talk about this in my next session, another commercial, about how limits apply for IOs within an instance type. And there's something to be very careful of when it comes to your storage. And you'll hear this in my next session. There's limits everywhere, and it's a matter of knowing where those landmines are to not step on them. So again, just enough for now. You heard me say this a couple times today, but it really is because of the convenience of resources of cloud that allows you to do this. No longer do you have to wait for a procurement cycle, going through finance, issuing the PO, waiting for storage to come in from your provider, and oh, there's been a flood in one of the factories, and now your storage is delayed 18 months, and that's gone. If Amazon or Azure or Google have that issue, that's a big problem. So, gone are the days of pre-allocating, and buying terabytes upon terabytes of data just for growth. Yes, question?
So what's the frequency to make these changes? Can it be a daily occurrence? In other words, add more ions tonight?
Yes, I'll steal a little bit of my thunder for my next session. So yeah, so you can add, so there's different ways I/O is treated within the cloud providers. You can do what are called provisioned I/Os, where you can say, I want to buy X number of I/Os. But traditionally, when you get into storage, the size of the volume will dictate how many IOs they will allow you to do. For example, in AWS, it's 3 IOPS per gigabyte of storage is typical. Azure does something a little different. They have pre-sized disk types or disk sizes, P10, P20, so on and so forth. Each one of those has a fixed size, 256 gigabyte, 512, 1 terabyte, 2 terabyte, so on and so forth. And each one of those comes with a fixed I/O. Now, to increase your I/O gets a little tricky on how you want to do it. In Amazon, it's easy because you can just go in and say, well, all right, I'm going to increase my EBS volume from 1 terabyte, which can give you roughly 3,000 IOPS, to I need now 6,000 IOPS. You just go in there and say my EBS volume is now 2 terabytes. But there's caveats and costs associated with doing that. And I'll get into that more in my next session. But there's limits and costs to everything, especially when it comes to storage, and you want to be very careful about that. Any other questions?
How do you update, how do you extend the disk storage without interruption?
That's the joy of LVM. On Linux, I'll admit I'm not a Windows expert, but on Linux, the really cool thing is you can just do a VG or an LV extend. You can extend it dynamically, and that's one of the beauties of Linux. I believe if you're using dynamic disks, if there's any Windows experts here, please correct me, but I think if you're using dynamic disks within Windows, you can do the same principle.
When you extend it, does it concatenate it, or does it remain a strike?
It depends what you're doing on that. If it's just one EBS volume, so it's one disk from within, so if you're in Amazon and you allocate one disk and you went from 1 terabyte to 2 terabyte, there's no striping involved in that. It's just one disk. The Linux will only see one disk. So then it'll just, when you add that into, well, you won't actually have to even do anything. You won't even have to extend your logical volume if you don't need more space. If you just need more IOPS, it'll just happen automatically because AWS will allow you that to happen because there's inherent throttles within. There's nothing you have to do at all within the virtual machine itself. Great question. I love this. Thank you.
Do you have limits on ones per volume?
I'm sorry?
Do you have any limits on ones per volume? Can you dictate the number of ones per volume?
Yeah, so each cloud provider has different limits. So Amazon used to be 16 total EBS volumes per instance at a 16 terabytes max, so it's a lot of storage, 256 terabytes. I think they just recently upped it to 40 EBS volumes per instance, as long as it's on a storage optimized instance. There are limits, and it's contacting your cloud provider would be best to know where their limit, because they all vary a little bit. Google now has something like 40,000 disk volumes can be attached to an instance. I think it's in beta, but it's a ridiculous amount of disks you can allocate.
So if on-premise you find that you have best performance without the small ones, can you duplicate that in the cloud, or duplicate what you get?
You're really stealing my thunder, yes. Yeah, I have a really good example in my next session that shows how you can do that and how you can actually work around some of the limits, especially when it comes to cost of storage space versus the number of disk devices. So yeah, I have a perfect example that it discusses exactly that. But yes, to your point, yes, you can create smaller disks and use LVM striping to maximize I/O but keep your cost down. So just using a typical example here of pre-buy your storage, a typical legacy approach versus what you would do dynamically based on your actual usage. So here I have an example of is a little over 6 terabytes of disk, assuming maybe a 10 to 12% growth rate. So the graph here is showing in blue my total storage allocated in terms of disk space. The green bar is showing what you're actually consuming or using within the virtual machine itself. So you see it's pretty much a fair amount of waste of space and cost that goes with it. Now if we look at the cost associated with that, so that pre-flat 6.2 terabytes allocated, from month 1 through month 12. It's around $617 a month. It doesn't sound like much, but when you total that out, it's $3,100 a year just for that space. But when you compare that to what you actually used, it's a significant saving. There's over a 40% savings of what storage you used versus what you allocated. So knowing your usage model, knowing your growth patterns, it goes a long way to save a lot of money. And that's just on 6 terabytes. Now, you have mirroring in there, disaster recovery, so now that's 2 times, 3 times plus the savings on storage costs. Question? Yes. So the question, just to repeat for the recording, is how can you automate that allocation so it's not a manual process? And I agree, having user or manual intervention is fraught with error. I mean, operator error happens. So using cloud scripting capabilities, AWS CLI, PowerShell within Azure, Google's capabilities, you can do that. We can interface into Iris, call our APIs, do database free counts. You'll know what your database usage is on a per day basis or per hour if you really want to. And based off that, you can build automation around it to pre-expand your disks just by simply calling out. And that's really the beauty of when it comes to cloud resources. And that's one thing I also wanted to touch on, or I purposely glossed over when I said what does cloud mean to you is, we talked about cost, convenience, and ease or not, but really the provisioning capabilities and automation capabilities of cloud is one of the other major benefits, but I purposely left that out. Yes, sir.
So you're talking about like using the tools to see database size. Is that something available in like P buttons?
P buttons will certainly give you that information. So there is data within there. You can call. There's the one of the dollar system database. I'll look up the API for you to actually call in to get it for either system, whatever's in the entire instance, or you can do it on an individual database or a volume that you care about. So yeah, I'll look up the API for you. I don't know it off the top of my head. Any other questions on this? Good? Okay. So we mentioned earlier about, there's limits on IOPS, and there's also limits on your megabytes per second. Azure and Google, again, same concepts. The size of the disk is going to impact your amount of IOPS. Like I mentioned, I'll pick on Amazon because it's fresh in my head. There's 3 IOPS per megabytes. Now, there are some bursting capabilities, but generally that's the rule. Again, commercial for my next one. I'll show you actually how and what happens when you bump into those limits and what happens to storage response time, user processes, and I'll show you exactly what happens. But basically, when it comes down to this, whatever limit is hit first, so they impose a lot of different limits. It's based on IOPS, based off of megabytes per second, and also down to the instance type itself has limits, and also your subscription itself could have an overall cap. So if you have your subscription might only allow for 100,000 IOPS total. And regardless of how many instances you have in there, EC2 instances or virtual machines, you can bump up into that. So that one's kind of when it comes to a subscription, that's usually a pretty easy call to the support desk of the cloud provider, and that's a soft limit, and they can bump it up for a fee. But it's doable.
Limits based on this type.
This type and size.
What are the disk types? Are we talking about spin disk versus SSD?
Yes. So the question is about which disk type. So every cloud provider has a little bit different options for disks. I'll use Azure as an example. So they have their premium storage accounts, which are SSD only. So they have one kind of SSD. They're P10 through P80 or something like that. And what dictates that is the size of the volume, and with that size comes with a fixed number of IOPS. And then they have their standard storage, which is their spinning disk or their standard HDD disk, where I think the max you can get on those is something like 300 IOPS. So there's use cases for those. For production, Again, my recommendation is only ever use flash. Spinning disk is great, and it's cheaper, of course, for non-production dev tests, long-term archive. But then I'm going to get in here a little bit of different kind of storage tiering. So when it comes down to the local storage or the ephemeral storage, EBS volumes, and I'll use EBS or the elastic block store. There's a couple types of them, but they're iSCSI based, and because there's there's finite resources around that bandwidth because it is iSCSI based, so there's the physical port on the back of the host comes into play. Ephemeral storage doesn't have that limitation, and I'll get into that in a little bit. And again, it's non-persistent, persistent storage in that it doesn't survive an instance restart. I'm not 100% sure, but I think if you do a reboot, like within the Linux VM itself, if you say reboot the VM, I don't think the storage goes away because it's not the actual cloud console that's doing the restart. I'm not 100% sure on that, but that might be something to check. And it might be a case where it might work for you one time, but maybe not the next time, so you want to be a little careful with that. But I'll show some cool things in my, and actually in the next few slides that shows how you can potentially leverage it. So then there's also, so we talked about disk or block storage. Amazon has, within their EBS, their elastic block store, they have GP2, they have IO1. GP2 is their general purpose flash drives. It's good stuff. It's pretty much what most database, anything you want persistent, goes there. Then they have IO1. IO1 is the provisioned IOPS, and that's for the cases where you have a small file system or you have a small disk, but you don't want to pay for 6 terabytes or 10 terabytes. You can say, well, I only need 500 gigabytes, but I want 10,000 IOPS. They'll allow you to do that, but you're going to pay a premium for it. So it's pay me now, pay me later kind of thing when it comes to that, when it comes down to IOPS and storage, again, because that's the only thing that can't be oversubscribed. That's going to be your most costly unit within here. But then getting into object storage, your S3 buckets. So now, Iris can leverage these, but it's all API based, so it would be up to you programmatically to interface with these. So we just can't put a database on here, mount it, and just have it go off and just run normally within Iris. We don't have that capability yet, or maybe it won't. I don't know, but I just know it doesn't exist now. I don't know, and I don't believe anything like that on the roadmap to support that. Then there's also Glacier. So S3 is great for anything that's application specific. Like I said, you put archives out there, application specific files, images, blah, blah, blah. You put it out there. And then you can tier off of that using going to offline storage, Glacier, where it's really pennies on the terabyte kind of thing. The cost about that is S3, or the difference between those is S3 allows you for immediate retrieval, so it's there. The difference between that and Glacier not only is the cost, but also I forget what the time limit is between it, but they'll say, well, it'll be available in X number of hours because it might be coming from some offline media tape or some offline archive media. Any questions? Oh, I want to go back 1 second. I skipped over it here. EFS, or the Elastic File System. This is interesting, especially for Linux, because we do support NFS-mounted file systems for databases within Iris. One thing to note is EFS does not have the same IOP capability and latency that EBS does. But this is great for things like if you have a lot of web servers and you have a lot of static content, it's great to put it out there. That way you're not doubling up on storage for things that are duplicated. Maybe even for a backup target, you want to have a central repository. So using our internal online backup, should you want to use that, that's a great target for this kind of thing. And EFS is really built well for handling higher throughputs of like megabytes per second, not so much IOPS per second. The latency is going to be a little bit higher, but you can shove a lot of data down that pipe at one point in time. So EFS might be a good point or a good usage area for things that don't need to be latency sensitive.
You have to worry about caching,
Caching at which layer?
storage.
So we do support, I believe it's version 4 NFS from the client, and we can do client-side caching. So it'd be just as default as any NFS. It's not specific to AWS. So if caching is something that's important and you're worried about stale data being referenced, you want to be mindful of that, and you want to tune your NFS mounts accordingly to handle it. You can either disable it or not, or have it time out after X amount of time. So you want to be mindful of it. So we're going to compare two different deployment models. So option one, it has the characteristics we have listed here. There's pretty simple, Amazon deployment. It's more of the traditional type deployment where you have 2 mirror members, maybe a DR async mirror member, and that 6 terabytes I mentioned earlier, maybe 3 terabytes of EBS snapshots for a month, and maybe 100 gigabyte of an EFS for NFS shares or something like that. Second option is an alternative to using a heavy EBS-based or laden deployment, and uses slightly different operational practices when using local storage on the primary and the backup mirror members, and only use EBS on a DR async mirror member. You can mix and match these a little bit, but I just want to show these here just to show you the cost comparison. I won't get into the performance other than I'll say one is much, much faster than the other. I'll go into details in my next session. So here's a diagram of what option one looks like. So we see here we have 3 different availability zones with a mirror member in each of them. Each of them has their own EBS volumes, snapshots associated with each of them, maybe some S3, and we're going to push EBS snapshots to an S3 bucket, and then we have our EFS file share repository. Simple, this is typical. We see a lot of customers do this today, but it's expensive. Well, it's more expensive, let's just say that. Any questions on this pretty simple architecture? Going to option 2, go back a second. So we see here it's almost $6,000 a month for this option. So going now to option 2, significantly less, a lot more simple deployment, and it's orders of magnitude faster in terms of IOPS. And I mean that literally, orders of magnitude. And you see the cost savings associated with it. Now, one of the challenges is like, oh, geez, you mentioned earlier that the local storage is going to go away on an instance reboot. That's where automation comes into play, leveraging your EBS snapshots from your async mirror. So your backups will be taken from a DR async mirror member. So what you can do is, should one of those or both of those mirror members die, that's a bad day that you're losing both your primary and backup mirror member. So if you do happen to go back to, your DR becomes promoted to primary, you want to rebuild your other mirror members that have failed, you'll pull from the EBS snapshot, match it back up to, have it rejoin back into the mirror member. It'll automatically resync, and then you can fail back over to it. And same thing for the other if you happen to lose both mirror members. Any questions on this? Simple, yes?
So Mark, what's the scenario where you would have to rebuild the mirrors? Like what happens? Disks went away?
Yeah, well, the disk went away, the instance went away, and that's kind of the little scary part about it. The rebuild, if the instance went away, you have to rebuild the data. So you have to either pull it from an EBS snapshot and rebuild it, repopulate it, you have to reseed it. You're basically doing a little mini recovery of the system. The neat thing about the EBS snapshot is you can mount it up as a file system. You're not getting huge amounts unless you want to have an EBS fully hydrated, if you will, to get the full copy of the data, to copy it. But for the purpose of populating local storage, there's no need. Just mount the EBS snapshot itself, copy it to the local storage, and then you're done. So just to recap, so there are numerous options to reduce your costs, to get the same or better performance. Again, such as, the local storage, will definitely lead to better performance and avoid those I/O limits. I'll get into the I/O limits in my next session. But there's, and if there's one thing to know about storage performance in the cloud, there's limits everywhere. And knowing where those limits are is really important. I know recently we had a lot of discussions with some customers about that, where it's like, well, why is my storage latency, I need deep C to run faster. Why isn't it going faster? Well, you're hitting a limit of the cloud. It's not because it was. So if you have any questions, doubts, or you want to think about going to cloud, please reach out to our group. We'd love to help. Quick show of hands, how many here are already on cloud or thinking of going to cloud? Great. Those that are already there, or you just, let's say, planning to go, let's do that. Already there? All right. I hope this has been helpful. So here's the usual slide. Please, fill out the survey. Any questions? I'm here for the next hour and 15, actually. I'm sorry? The question is it more cost effective to go to cloud than on-premise? Yes. Yeah, this is where right at the very beginning where I said cloud can be expensive, but it doesn't have to be. If you take traditional modeling and traditional sizing and you carry that over to cloud, cloud will be much more expensive over say a 3 or a 5 year period. Cloud will be much more expensive to do that. But if you're smart in allocating your resources of the just in time and just enough for now, cloud will be much more cost effective in the long run. And you don't have to pay for, upfront. The other really nice thing about it is you don't ever have to worry about technology refreshes. You never have to rebuy the same terabyte of disk twice. Yes, it's an OpEx, absolutely. And with that, I thank you.